everyone. Is it working? Yes. Okay. Hello, everyone, and welcome to our lecture, Hacking with Polyglots. I am Szymon Pach. I've been involved in security for around 11 years, since my high school years. I'm working at Akamai Technologies, and we are both in penetration testing team. I like doing do-it-yourself stuff, like building Wi-Fi antennas or radio antennas in general.
Hello everyone, so my name is Dawid Mazurek. I'm also security engineer at Akamai Technologies. I graduated from Wrocław University of Science and Technology with my specialization in cybersecurity, with majority in data security, but my journey with hacking began while I was attending to White Hat Students Association, and I've spent 1.5 years in penetration testing team in EYGDS Poland.
We'll tell you what polyglots actually are, how and why create polyglots. We'll dive a little how to create JPEG and a JavaScript polyglot. It's a file that's simultaneously a JPEG and JavaScript. Also, we'll dive a little how to create PDF and zip polyglots. We'll explain why cross-site scripting payloads can be polyglots too. We'll tell you how to defend against polyglots, and there will be time for questions. Okay, so what is a polyglot? Polyglot is a file or a programming code that is crafted in such a way that can be interpreted as at least 2 file formats or programming languages. And those can be interchanged. I mean, we can have an image that is programming code. That's why we call them polyglots, because they can speak multiple languages. And they are nothing new. They've been known for around 30 years. And the first official polyglot, I mean, the code that was called a polyglot, it was crafted in 1991, and was able to be run in 8 languages, as shown here. Okay, our first example, this is a polyglot. It's from online forum where users challenge themselves to craft polyglots. Like each next post will be with 1 more language. It's the second post. It's in 2 languages. It's Python and in V. V is esoteric language inspired by Vim. That's why I put, because there are other 2 V programming languages. Okay, so how does this work? In Python, of course, print1 will print 1 in the console, and the hash sign is commenting the rest out. So I too won't be doing nothing. If we run this as V, then print1 and the hash sign is no OP, which means it's no operation. It will do nothing. It will be skipped. And I is for inserting things, and it will insert 2 because 2 is after it. Okay, so this is a little bit later on this forum, and oh, I spoiled it. Can you guess how many languages it is? For those who didn't see, it's 25. And this is the last post from this forum. We won't be diving how to read this. I removed also a lot of comment lines, I mean line breakers, so we can feed this into 1 slide. Can you guess how many languages that is? It's 402 languages, which means this can be run in 402 languages, and if you run it as Python, it will print 1, if you run it as V, it will print 2, etc., and so on until the 402nd language, which is, who knows, I don't remember. Okay, so what about file formats? We can merge a lot of file formats, but there are limits. With languages too, but those limits are kind of faded, because after some time people find new ways how to merge like a few programming languages into 1. And with file formats, it's a little bit harder, because those are binary files. There are much more than just those, but I wanted to show you something. And a small interesting fact, if you take the executable file on Windows, you can make it into a polyglot with HTML and PDF only. If you do it with HTML only, it will not work. Same with only PDF. It has to be HTML and PDF, which is kind of weird.
So now I will try to explain to all of you how to create polyglots. It's usually hard, because it requires a good understanding of how binary files work and what is the structure of our file, but sometimes it's very easy because we can do it with simple concatenating of two different formats of files, due to the fact that some kind of formats do not enforce data at offset 0. So we can easily tolerate appended data at the beginning or at the end of file which we are using. The specific file formats which allows us to append data, mostly it's our all archives files. As I said, it can be created with simple concatenation. And here, as you can see, in the bottom of the slide with examples, question mark stands for any type of file we want, and we can easily to this file append some kind of archives, PNGs, or MP4s, and there should be no issue with running this file. And also at the second line, at the question mark stands for any file we want, and it's on the end of the file. And at the beginning of this file, we can easily append also archives, JPEGs, MP3s. The interpreter of this file should not display any error due to the fact that the structure is created. No worries. Yeah, so let's go further. Why we are creating polyglots? Polyglot files allows us to bypass a lot of things, especially file restrictions. With polyglot file, we can easily bypass the file type restriction. So if our server or our application allows us only to send or upload, for example, PDF file, with this polyglot, we can easily upload the zip file, and for 90% of chances, it will not be detected, but we will present it to you later. What are the benefits also for polyglots? With polyglots, we can easily deliver some kind of malware, and it's very great for social engineering. And also, we have a lot of attack vectors which we are using in polyglots. For example, XSS, SSRF attacks, content smuggling, and much, much more. But there is no time to explain all of them.
Okay, so let's dive a little how to create a JPEG in JavaScript. So how can image be an executable code? I mean executable like not in executable file, but just a text file. We'll start with JPEG because they are a little bit more complicated because they are binary files. And what does binary file mean? Okay, so basically it works like this, that the file is read as a stream of bytes. So those file signatures, or magic bytes, as people also call them, are the bytes that you will see at the beginning of the file, if you are reading the bytes, for each JPEG, for each PNG, and there are, of course, much more. For every binary file, there will be some special file signature. And starting the file means it will be at offset 0. Offset is how far from the beginning of the file bytes are. But we are interested in the JPEG, so let's try to understand what those bytes actually mean. FFD8 is a start of image marker, and you could see it here. And okay, so sorry, I have kind of I'm a little bit stuck. Okay, never mind. I want to say one thing, but I forgot what it was. Never mind.
Chill.
Okay, so thank you. So JPEGs are basically divided into markers, and some of those markers indicates the starts of the segments. Basically, they indicate something. For example, if JPEG decoder wants to see FFD8 at the offset 0 at the beginning of the binary file, it will not read this file. It has to be at offset 0, and just how it's constructed. And all of those markers that you see here are, except the comment, but I put it here because we'll be using it later, are a bare minimum for a JPEG file to be valid. There are much more markers than those, but those are the bare minimum. And you don't have to understand how this works exactly, but you just need to know how they behave. Okay, so one example, this is a shrike. Shrike is a bird. It's dzierżba in Polish. And this is shrike JPEG. And those are first 32 bytes of this image. So as you see here, marked on red are two markers, FFD8, which means start of an image, and FF0, which is application segment 0. And each marker starts with FF, always. And in this case, FF is 0, application segment 0. It takes an argument. This is a 2-byte argument, and this argument indicates how long the whole segment is. And the segment includes this argument. So this is the whole segment. On the blue, on the green, we have marked the argument, and on the red is the data itself in the segment. So basically, that's how it works. We have markers. Some of the markers takes argument, and some of the markers build segments. And there are markers also who just takes only arguments. Okay, so what makes a JavaScript file? This is a text file, so nothing really. Those are just encoded characters. There is no file signature for text files. Like each file will start whatever you write in it. In this case, this file at offset 0 will be having 76. Okay. So how do we merge those? Like how we can connect a binary file and a text file? The first thing we can do here, I mean, there are a few ways of creating this polyglot. I'm showing one of those. And in this way, we can change the length of this segment. Those 2 bytes marked on green, in green. And if you change it from 10, which is 16 decimal, because those bytes are in hexadecimal, if we change it to F to A, and if we run it as a JavaScript file, this will be interpreted as opening of the multi-line comment. And JPEG decoder will accept this, but we'll need to pad this segment with zeros. So this is around 12,000 zeros. And if you are wondering about those first 4 bytes, those will be interpreted as YOYA, and that's how we'll be referring to those bytes from now on. Those are non-ASCII characters, so we'll need to change character encoding when we'll be running our script, but it will work. And if we modify it, it will look like this. So the original segment is green and red, and then we have 0, 0, 0, and 12,000 of those. Now the comment. How the comment works, if you remember from the application segment 0, it's the same way. On the black, those 2 bytes, FF and FE, are just a marker for JPEG decoder to understand that the comment is starting. On blue, we have the length of the segment, and the segment is blue and orange is just 2 zeros encoded. And how do we put the comment in a JPEG file? Well, it's very easy. Just find a place where some segment ends and another segment begins. For example, like here. 0, 0 in red indicates, I mean, not the 0 indicates itself, but just mark that the segment is ending there. And another segment is starting, FFE2, which is application segment 3, if I remember correctly. And we can just put the comment right between those. And this will be valid JPEG image. Okay, so what do we put inside the comment? As you remember, we opened a multi-line comment, so now we need to close it. And we have these non-ASCII characters that will be a variable, and we need to use equal sign to do something with it. We can put, for example, like 2 here and a semicolon, and then we can put whatever we want. Comment must end, of course, with opening another multi-line comment, because we can't put, I mean, basically we can put a JPEG comment like wherever, with maybe a few exceptions, but it's best to like put it at the beginning of the file. I mean, first available place. So we need to comment out the rest of the bytes. So it will be valid JavaScript syntax. So this is example payload. It can look like this, like equals alert 9, and alert doesn't return anything, but it will be valid JavaScript syntax. And opening of the multi-line comment. So far we will have, if interpreted as a JavaScript file, we have this YOYA, weird 4 bytes, non-ASCII characters. opening of multi-line comment, some bytes until we place our comment in JPEG, and then we have closing this multi-line comment, some payload, opening another multi-line comment. Okay, so how do we close, how do we actually close this last multi-line comment? FFD9, those 2 bytes, indicates the end of image, end of JPEG image. After those, JPEG decoders will stop reading the file. It looks like this, like just last 2 bytes. And they will not read it, but sometimes some variations, maybe forks of some JPEG decoders, can actually check this and may report an error, or the image may be corrupted. File validation, on the other hand, if you want to defend against polyglots, some of those can actually check this, because this is the easiest way just to append something at the end. So file validation, during file validation, this may be checked, and this may be invalid. So the safer way will be to replace just those 4 bytes just before the marker. And if you are worrying about what those bytes are, and of course those bytes, those bytes that we will be replacing, and we will be replacing for those bytes, so we can close the multi-line comment and open 1-line comment, so we can comment out those 2 last bytes. And the bytes that we will be replacing are restart markers. Though those are automatically added in most JPEG images, in most cameras, like in phone, but are not really required. Those were needed when the internet was kind of young, and images were transferring through channels that could produce some errors. And the restart markers help with synchronizing, sending the image again if some packets were lost. But those are not really used anymore, and we have channels that are error-free, so we could replace those, and the decoder actually might find this. Maybe it will report an error, but as you remember, restart markers are not required for a JPEG image to be valid, so you can safely replace those, and it will work. That's an image. Okay, so to sum up how this works. First, we replaced those this argument for application segment 0, which is 2F to A now, because we replaced it. We have this yo-yo weird thing. We don't care about it. Then we put somewhere the comment with our payload. And then, just before the end of the file, we replaced those 4 bytes. And we hope to God those won't be needed. If there are them, because there actually can be some different markers or no restart markers. But there are pretty good chances that there will be restart markers and we can replace those. Okay, so some short demo. How this will work. Okay, so this is an application called Guestbook. We wrote it for this presentation. And it has some security controls. It's wrote in Node.js. It uses Malter for uploading the files. It uses sanitize HTML for getting rid of HTML tags, etc. And it's using Magic to detect if the file is actually the file we are uploading, which should be a JPEG. Okay, so how does it work? Well, if you write just something. So there's a little bit of delay.
There is a connection, but as we can see, there is loading, so wait a sec.
Oh no.
Change to the terminal.
Yeah, sorry guys, we should have recorded a demo.
Sorry guys. Some technical issue.
Yeah, we did it like 10 times.
Okay, it's working. Yep.
Okay, excellent. Oh, so this will be a bit longer.
Go on.
Okay, so I will skip a few things. You need to believe me that that actually sanitize anything we write there. So no tags allowed, except because this is misconfigured, of course, on purpose. if you run something like this, you probably don't see it, but I'm writing a script tag in HTML. Okay, and if you write, for example, a script. Okay, thank you. Okay, script source, like whatever, for example, X, and then something, something. And we are closing it, closing the script, and that's it. I just want. I never opened it. Source, like whatever, some code, and closing of the script tag. Oops. Okay, works. Cool. Okay, so I just wanted to show you that okay, this will be this one.
Yep. The closing marker, the closing tag is removed, so it's it.
Ah, yeah. Okay. Well, you just need to believe me. Basically, the vulnerability that's here is that anything we write outside of the script tag will be removed, but the script itself will stay. So we can actually use it, use the attribute source to use something that we upload there. And of course, this application won't accept any source from outside of its origin. Okay, and for creating this polyglot, I wrote very handy tool. Basically, you just give it an image, and it creates a polyglot for you if you give it a code. I doubt that you will see that, but this is the code that we will try to execute in the application. It's variable a equals, yep, this polyglot slaps. It will log it in the console, and we'll also see an alert if this will work. Right, so cutting corners here a little. David, can you open the application?
Yep. Okay. Just home. Where is it? Poly src.
Excellent. Okay, so we'll be uploading this image. I would show you how uploading a regular image would look like, but it just looks the same. And we don't have much time for this hands-on. Oh, okay. Works. I just uploaded an image. Cool. Now, the behavior of the Molter, the middleware in Node.js, turned this image into some random value. Ah, not this one. Yes, so sorry, it's a crazy delay. We will have a lesson to record the demos. Okay, I will be copying that. And I will be using that. I just need the address of the image. Okay. We'll be changing it to script tag, so I'm closing the script tag. Gentlemen in the front, please keep me honest if I'm writing this correctly. I have only one chance in executing this. No pressure. Okay. Yeah. Okay. Ah, yeah, there is one more thing. Normally, I would have showed how it looks like, but as remembered, we have this Yoya thing, the non-ASCII characters, so we need to change the charset, which is charset equals ISO 88591. Okay. Works. We hacked this, and this is of course a stored cross-site scripting. Works every time.
Okay.
Not the end.
Yeah, it's my part right now. So please, could you clear the application? Yes. And we've turned off the sanitization.
Yes, sure.
And where is clicker? Where is my clicker? Okay, so now I would like to present you how we can create a polyglot, which is not used for hacking with executing some kind of scripts, but it's a great for post-exploitation processes. Just imagine the situation where you are already in the victim's machine. You are storing some kind of logs from, for example, from keylogger, but you would like to hide it somewhere and take it to steal it. So let's see our simple PDF. Hey, here's my simple PDF. No zips inside, trust me. I would not. Yeah, we have to. So, but let's check. Just do double check what's inside and how this file looks like. So, we are checking the header in hexadecimal of this sample PDF. So it starts with 2550, and on the right side we see that it's a PDF 1.3 version. But what's interesting us more, we are checking this file with exif tool, and we are checking the file type, file extension, and MIME type. So everything seems like it's a real one PDF file. We have some kind of added metadata. You can see my name again. I'm Dawid Mazurek, so if anyone wants to ping me after this meeting. But how looks our zip file? Our zip file is nothing hard, just 2 images downloaded from internet, too simple without any scripts inside, as Szymon shows us. So let's go further. How this zip file looks like in the same perspective as we check the PDF file. So the header starts with 504b, and the exif tool is showing us that this is an application/zip. This is most important for us. How we are creating the polyglot file with simple concatenating. No more operation is needed. So we're just using the simple cat command, sample PDF, zip.zip, and as an output we are setting the polyglot.pdf. How this polyglot looks like. At the beginning, the header is exactly the same as our sample PDF. So the header is 2550. What is that? Because we appended data to our PDF file at the end. So the header is not changed. But if we are checking our PDF file with exif tool, the first part looks the same, but at the end we see some kind of warning, the invalid xref table. So it's telling us that there is something bad with this file, but does user see this? User is opening our polyglot file, and he or she see only, hey, here is my simple PDF, no zip inside, trust me. So what we can do with it? What was the purpose of creating this operation with zip file? The result is really clear. At the bottom of my screenshot, you can see that we are able to unzip the polyglot. And we do not extract some kind of text files which were in our PDF file. We are extracting our images which we hidden inside. During my first part of presentation, I showed you that the archive types can be combined with a lot of types of file. We can easily do the same with Java. We can easily create the HTML plus jar file with the same operation like here, and we are receiving the multiple possibilities to use our files. And as I said, this example is great for post-exploitation. Why? Because we are not hacking anything with that. We are just stealing and hiding some kind of data. So for this presentation, I prepared a little script which is responsible for creating zip file. Just will not go deep into this code, just a few points. We are creating our zip file with 2 images. we are concatenating these two files. The result of our operation will be polyglots polyglot underscore PDF underscore zip.pdf file. Okay. And just to make sure that no one will detect our operation, we are removing just the sample PDF file which we created during this. Yeah, we are created here. So let's clear that. Okay, let's just make sure. Okay, we see that we have our sample PNG image.png, and also we have sample PDF file. Yeah, here is it. So let's try to run this file, or maybe I will try to. Okay, here I will show you that this file really appears. Okay, so run it. Bang. Okay, polyglot PDF zip PDF file created. We are checking it. Yeah. The same file which I showed you on the slides. And when we are using this file again, just to highlight that, we can easily automate, we can modify this script to run it not only for static files, which I hard-coded, but we can easily gather the whole logs and hide it into our victim, to victims some kind of PDF. And maybe we will ask him for this specific file, just send it to us if it's our friend and we don't like him or her. So yeah, many possibilities. But now, yeah, that's all for PDFs and zip file. But let's proceed with presentation. How much time is it? 12 minutes. Yeah, that's good. Something about XSSs. Here we have our XSS payload, which can work in multiple contexts. At the bottom, you have the URL where we take this polyglot from. It's not ours. So how this payload works, there is specified. This is listed for what kind of operation, every part of this payload is responsible. There is a lot of operation. There are the multi and single line comments, something responsible for triggering some kind of alerts, the tag breakers. So on the first view, we see that it doesn't work. It's no possibility that will work. There is no valid syntax, but is it right? Just assume that our application is taking data as a value in HTML input tag. So how it behaves, the blue part of our payload is treated as simple string. Everything after the blue part, I mean the black part, is treated as HTML attributes. It's weird. It looks very weird in application, but it is how it is. The SVG element runs, is triggering the onload function with alert due to the fact that it's valid HTML syntax. But what if our application is not taking the value as a HTML input type, but as a variable to the string, some kind of string? What's going there? The similar situation. So blue part is treated as a string. All after the blue part is treated as is commented, so all of that is ignored. We are going outside of the script tag with simple tag breaker, and what's going there? The SVG element with onload function again runs. So maybe let's try. Oh, sorry, it's not the time for that. This is a list where we can use this payload. How it works. I will not go through all of that because it's time wasting, but we can use this single payload just to perform some kind of XSS attack. Error-based SQL injection XSS is the most interesting, probably. This payload is also used for filter evasion. Yeah. And again, here is the URL of this payload. And now let's try how this payload works in real life, in application. Okay, I can easily close that. I don't need that. I need this one. Okay, so let's copy that payload. Yeah, it's here. Cool. So first of all, I'm copying the whole payload into our application, and let's just little modify this with alert. Bang. 1, 2, 3. And here let's try to, where is the second alert? I'm not. 1, 2, 3, 4. Great. And just send it. 1, 2, 3 runs. Yoo-hoo. But no, it's not that. It's not that. Sanitization here is turned off, so it's not what we need. But let's check how it is treated by application. I'm in good place. Of course, I'm not. So this is this one. It's not this one. So it's, yeah, it's here. Here, as you can see, the JavaScript is treated as a string in value. All after that is treated as an attribute, weird attributes. So here should be some kind of syntax error, but here's not. And after that, we have our SVG element with proper syntax, and as we saw, it was executed. It's executed. But now let's try to here. F5. Never mind. Clear. Clear. Okay, I just cleared our application just to don't be interrupted by previous alert pop-out. Let's insert the same input without input tags, because we want to see if it's working, if it's still working. Is it? And again, let's just alert. Nope, here. 1, 2, 3, 4, 5, 6. Send. Bang. It's working again, but why? It's without. It's just a string without input tags. Application should treat this like just a regular text with no executions, without anything. But what happened real here? It was the same payload, but with tag breakers. With our closing script tag, we go outside of the script tag, and we just run our SVG element with alert 1, 2, 3, 4, 5, 6. And it shows us that the simple payload, one simple payload with the same function, was treated in 2 different ways. So it shows us that, as I said before, one payload, multiple contexts. It can run also there was a CRLF-based XSS. Funny thing, someone could say this is impossible, but this is how the polyglots work, and this is the opportunity which they gave to us, which we can just use it and taking all benefits of it. But the most maybe interesting for all of you, how to mitigate this kind of attacks. So the best approach to prevent the polyglots is providing details about the context in which the file will be treated, in which how we interpret it. For example, sending the expected type of file, I mean, what kind of file we are expecting, and comparing it to the file which user sent to us. So, for example, we are expecting PDF, someone sends to us the HTML, we should pop out some kind of error or just block the user. Of course, the most obvious mitigation for XSSs is the server-side filtering of specific syntax. In the brackets, I inserted the removing comments. It's regarding the Szymon's part with removing the JPEGs and JavaScript comments from file. But I know that filtering of HTML syntax to prevent cross-site scripting is very difficult due to the fact that it's many ways to how JavaScript can be delivered, and filtering all potential harmful payloads is hardly possible. But in case when we exactly know what kind of file we are expecting, for example, if we are just expecting only PDF, we are not taking care of any different types of file. We are just checking if our PDF file is only PDF file. Anything after that should be ignored. What applies the third point, use a proper file structure validation. So this point also applies to the checking the code, and I know that's very hard. However, here we should focus on different perspective. Here we should focus on the file structure. Know what code is inside, but how our file looks like. So we just have to know how the file starts and how it ends, and we should ignore or remove everything after or before our file which we are expecting. Thanks to that, we can order the interpreter to ignore rest of the file which is probably harmful for our system. The best practice to prevent content smuggling is, of course, using the sandboxed environment, which means that every user-supplied content should be hosted from sandbox origin, just to prevent that our attacker will not have access to other user the data. And the last one, disallow to overriding the MIME type provided by the server. So unfortunately, browser vendors have allowed the browser to override the MIME type provided by the server as the compromise to deal with the situation where the server doesn't know the content, was confused as what kind of content it is serving, but only browser vendors can help to mitigate this issue with limiting the content which can be considered to be interpreted. So there is only hope that the browser vendors will help us to mitigate this issue, and they will stop doing these stupid things that's allowing this kind of attacks. That's all from our side. We hope that we fulfill your expectations regarding our presentation, and I would like to thank you all for being here.